So are you trying to understand wrapper classes in Java? If so, this video is for you. So in this video, I will go over topics related to wrapper classes, including an introduction, an overview of primitive data types, answer the question of what are wrapper classes, go over autoboxing and unboxing, common pitfalls and best practices, and then I'll do some coding examples. As always, this video is timestamped. So if there's a specific topic you came for, you can skip to that section. So let's get right into it and let's tech talk with Tyler. So wrapper classes in Java serve as essential tools for developers, acting as middlemen between primitive data types and objects in the Java programming language. So they encapsulate primitive values within objects, allowing them to be manipulated and utilized in an object-oriented context. The primary reason for employing wrapper classes includes adhering to the object-oriented paradigm, enabling the representation of null values which primitives cannot hold, and facilitating the seamless integration of primitive types into Java collections frameworks and generics. So understanding the list of primitive data types, such as byte, short, int, long, float, double, char, and boolean is fundamental to grasping the utility of the wrapper class. So in Java, primitive data types are the basic building blocks for storing and manipulating data. The int data type is used for integer values, while char represents a single character. Float and double are used for floating point numbers, with double providing higher precision. As we learned earlier in the video, wrapper classes in Java serve as the bridge between primitive data types and objects. They wrap primitive values such as integers, characters, floats, and booleans, allowing these values to be treated as objects. The integer class, for instance, wraps int values, while character wraps char values, and similarly for other types. So the naming convention consists of this. The name of the wrapper class begins with a capital letter corresponding to the name of the primitive type it wraps. So for example, the wrapper class for int is integer with an uppercase I, and for char, it's character. So this convention just simplifies the identification of the relationship between primitive types and their corresponding wrapper classes, making it easier for developers to work with both primitive and objects seamlessly. So wrapper classes in Java offer a range of features that enhance the utility of your program. They enable the conversion of primitive types into objects via wrapping and vice versa, unwrapping, providing the flexibility to work seamlessly with both primitives and objects. So these classes offer a set of common methods and constructors that facilitate various operations. So similar to what you see on the screen, constructors such as integer, int, and double create instances of wrapper objects, while conversion of methods like parse int, string, and value of int allows smooth conversion between strings, primitives, and wrapper objects. Comparison methods like compare to enable the comparison of wrapper objects, aiding in sorting and ordering tasks. Additionally, utility methods such as parse int, string, and toString provide essential functionality for parsing and converting values. Autoboxing and unboxing in Java are two features that simplify the process of working with primitives and their corresponding wrapper classes. So, as it sounds, autoboxing automatically converts primitives into their objects, just enhancing the code, which enhances code readability and simplifies assignments. So, for instance, converting an int to an integer object is performed automatically without explicit code. This feature not only simplifies the code, but also ensures compatibility with collections and other data structures that require objects. The advantages of autoboxing include code simplification, increased clarity, and improved compatibility with APIs that work with objects. So on the other hand, we got unboxing, and that does the opposite of what autoboxing does. So it automatically converts wrapper class objects back to their primitive types. So for example, the integer object can be converted back to its int without explicit casting. So unboxing is particularly useful when working with collections that store wrapper objects, allowing developers to seamlessly retrieve primitive values. Understanding autoboxing and unboxing is crucial for Java developers as it streamlines code, enhances readability, and ensures smooth interactions between primitive data types and objects. So, what are some practical use cases? So, wrapper classes in Java serve practical purposes in various real world scenarios. So, in GUIs or graphical user interfaces, database operations, and web development, objects are preferred over primitives, thus, wrapper classes come into play. So, for instance, in a GUI application, if you need to store ages entered by a user, you might want to use an array list, which requires objects. Wrapper classes like integer can wrap the primitive int values, allowing them to be stored in the array list. Additionally, wrapper classes are vital when parsing and forming data. So, when dealing with user input or data from external sources like files or databases, the data often arrives as strings. Methods such as parse int string in the integer class allow developers to convert these strings into integers for further processing. Similarly, formatting methods in wrapper classes assist in representing data in desired formats, ensuring consistency and accuracy in various applications. Also, handling collections such as array lists, which can only store objects, is made possible through the wrapper classes. Since primitives cannot be directly stored in collections, wrapper classes like integer, double, or boolean are used to wrap primitive values, enabling their inclusion in data structures. So this capability is particularly crucial in scenarios where large data sets need to be managed efficiently. When working with wrapper classes in Java, it's essential to be aware of common pitfalls and best practices to write robust and efficient code. So, number one, null pointer exceptions can arise if you attempt to access methods or properties of a null object. So, to avoid these errors, always perform proper null checks before accessing methods or properties of wrapper objects. This practice ensures that you handle null values appropriately, preventing unexpected runtime errors. In terms of performance considerations, it's important to note that wrapper classes have additional overhead due to the memory and processing requirements of managing objects. So, in performance critical applications, using primitive types directly can be more efficient. However, modern Java versions often have optimizations and performance difference might not be significant for most of the applications. So it's crucial to profile your code and choose the appropriate type based on performance requirements and constraints. So if you're creating something that's just for yourself, maybe you could use it. But if you're creating something that requires low complexity and low overhead, such as a large scale program, do some research on that. So when it comes to choosing between primitive types and wrapper classes, the decision depends on the specific use case. If memory constraints are concerned, primitives are more memory efficient. However, if you need to represent absence of data using null values, or if you're working with collections and need objects, wrapper classes are your best bet. Consider the context of your application, the need for null values, and performance requirements when deciding between primitives and wrappers. Choosing the appropriate type ensures your code is both efficient and effective, aligning with the best practices of Java programming. So the first question says, write a Java program that demonstrates autoboxing and unboxing with wrapper classes. So let us first focus on autoboxing and convert an int to an integer. So let's create an int variable called num, and we'll set it to 42. And now we will autobox. So integer num, let's name it num object equals num. And this is just an example of autoboxing. And now we will do unboxing. So we have integer num object 2 equals 50. And then we will unbox it. and say int num2 equals, oops, there we go, num object 2. And there we have it. So basically what we did was the first part we autoboxed, which converted the primitive int to an integer object, and then part 2 we unbox, which converts the integer object back into an int. Question 2. Write a Java program that checks if a given integer object is null. All right, so we have our class and we have our main method. So let's create an integer object. Integer num object equals null. Let's set it to null. And then now let's check. Let's do a null check with the wrapper class. So if, and then inside we'll have num object is not equal to null. What should we do? Let us print integer object is not null. Else, we will just print the opposite. So let's just copy this and say integer object is null. So in this program, we check if the integer object num object is null. If it's null, the program prints integer object is null. So question 3, write a Java program that converts a string containing an integer to an integer object and calculates its square. So let us first just create a string variable. So string number string equals, so let's say it's 25. And we can name it number string like this. And then now let's convert the string to an integer object. So we'll have integer num object equals integer dot. And what are we going to do? We are going to parse int. And then within these parentheses will be our string. So it'll be number string. There we have it. And so let's just do that. Let's use the uppercase notation for naming. So num uppercase O for object. And then now let's calculate the square of this integer value. So int square, we'll create a variable equals, and it's pretty much the square. So the square of num object times itself. And then if you want, you can print it out. So in this program, we convert a string containing an integer to an integer object using parseInt method. Then we just calculated the square of the number and printed the result. Question 4. Write a Java program that demonstrates the usage of array list with wrapper classes to store integers. So let's first just create an array list. Array list, and it's going to be of type integer. Oops, integer. And keep in mind this is uppercase integer. And let's just name it numbers equals new array list. And let's add some integers to the array list using wrapper classes. So numbers dot, let's add, use the add, all right, 10. Numbers dot add 20. All right, so now let's iterate and print elements. And let's use an enhanced for loop. So integer, and it is num and numbers is what we will be iterating on. In this program, we create an array list of integer objects. We add integers using the wrapper class integer, and then iterate through the array list to print the elements. Question 5. Write a Java program that compares two integer objects. All right, so we must create two integer objects. So integer num1 equals 20, integer num2 equals 20, 10, let's say 10. And now we'll just compare the two objects. So how should we compare the two objects? Let's create a result variable, and we'll do the compares to num2. And there we go. So the compare to method will compare the two numbers, and it'll give a negative, 0, or positive result. So if the result is less than 0, that would mean that num1 is smaller than num2. Else, if result is greater than 0, that would mean that num1 is larger than num2. And then we'll have just another else to cover that they are equal. In this program, we compare two integer objects, num1 and num2, using the compare to method. So depending on the comparison result, the program prints whether num1 is smaller, larger, or equal to number 2. Write a Java program that demonstrates the usage of the Boolean wrapper class. So let's create a Boolean value. Is Java fun? And let's just say true. So that means yes, because it is fun. And then we'll just create an if statement, a quick if statement. So if is Java fun, and this just means if this is true, then we will print, I'm just going to use the same system.out, then we will print Java is fun, else Java is not fun. So in this program, we use the Boolean wrapper class to represent a Boolean value. The program checks if Java is fun is true and prints a corresponding message based on that value. And that's all. So these 6 examples demonstrate various aspects of wrapper classes and related concepts discussed earlier. So they cover autoboxing, unboxing, null checks, array list usage, comparisons, and practical applications of wrapper classes. So that's all that I have. I hope this video helped you understand wrapper classes a bit more, and I hope the coding examples were informative. If you enjoyed this video, please hit that like button and subscribe to my channel. Also, if you have any comments, questions, or requests for other technical topics, please leave a comment down below. Also, do you want all the information in this video on one page? If so, head to my website, tylerlcrawford.com, to get your hands on my cheat sheets that I created. Best of all, they're super cheap. Once again, thank you for watching my video, and I'll see you in the next one.